Welcome. In this video here, I'm going to go over that's the cam simulation for the 4-link housing bracket for the Quarterscale Pro Mod rear end I'm designing. I'll briefly go over this here in a notepad here on it. I am keeping track of all my operations so I can have a total time of everything once it's all complete. And this is the same program I opened up in that other video prior to this one. As you can see here, it says 4-link housing bracket single. This is a single part. It takes 3 minutes 21 seconds. Comes in at 255 lines of G code. Want to set it up if possible to do 2 parts at once, but with my limited accesses in X and Y, that may be a bit tricky to do. I'll cross that bridge when I get to it if I do decide to go that route. First thing I'll go over here is we'll go over to cam. This is what the part looks like in cam. I have it running horizontally rather than vertically like it will be on the rear end. Primarily because of my y-axis travel on the mill. I have just over about 4.5, 4 3/4 inches. This is close, don't remember right offhand exactly, close to 4 inches wide, 5.5 inches long. So actually it's the other way around. When placed on the rear end vertically, it's a little over 5 inches tall, the bracket on the rear end, 4 inches wide. And I'll briefly go over what it actually looks like in my solid edge drawing. This is one of the drawings that I'm doing on it. As you can see, these are identical. Not if I were aware if I've mentioned it in any other videos here, but this is just a mirrored image of I draw one of them, and you draw a line down the center. It don't have to be center. You can put a line out right off the side here if you want to be closer together or further apart. Then you just go up and you hit select all. I won't do it in this video, but you just hit select all. Then you go to mirror, and you hit mirror. It'll highlight that whole rear end in pink or whatever color you have set in your properties. And you hit your center line there, and it mirrors it right over to the other side. And then you just go back and delete whatever materials or parts that you don't want in there for that drawing. That's pretty much what I'm doing here. If you look close at it here, you can see this is the pinion gear right here. Obviously that's the ring. If you look over on this side here, you can see that's the ring, but you don't see the pinion because that's on the opposite side of the gear. In this drawing here, I was doing 2 tasks at once actually. Obviously these are the 4-link brackets that this video is basically on the cam. This is also the carrier for the ring I'm designing. The bracket does bolt the same bolt pattern as the carrier, but on a 1-inch radius. It's a little bit smaller than that. Pretty much the same design as far as bolt pattern there goes. I just put it on a smaller radius. I just want to show you this real quick, like over in my CAD program, what it looks like. This is to scale. This is 1:1 quarter scale. I'll briefly, real quick like here, I'll show you a few dimensions here, so you can see how I do it as well. You select your highest point that direction, and being that I already know where they are, your highest point this dimension. And remember I mentioned over that cam is close to 4 inches, it's 3.472, but that was with no offsets. And I just right click to remove that, come down here and I do the same thing. This is the total height, 5.139, again with no offsets. In the cam drawing I got a 3/16 offset drawn all around this actual bracket, and we'll go back over to cam and you could see the offset. If you look at that white line on the inside, that's the actual dimensions of the bracket. My offset is on the outside. This is the setup is set at 100%, so these are the actual tool sizes. I'm going with a 3/8 2 flute end mill for this contour on the outsides. That makes up my difference in my offsets there. If I go with a smaller tool, it would be close to that line, but not quite close enough, so actually the bracket would be just a little bit bigger. Same applies if you went with a 9/16 or anything bigger than a 3/8, ½ inch even. Your inside line would be a little bit smaller, so you'd be making that bracket just a little bit smaller. For the rookies out there, you need to take that into consideration when you're loading your CAM program. Actually, try to think well in advance before that even. I try to. Every now and then I do forget to do that in my CAD program, that offset or whatever your center difference is of your bit, or if you want to run from the outside as your offset. There's inside offset, outside offset, no offset. I'm running no offset on this one, so it will follow that inside line. And what I'll do, probably, this is 1/8 inch aluminum. 2 brackets will actually make up one bracket, one side for the rear end. There'll be a bushing that's placed in between the brackets. I'll cut them, mill them all too. My main purpose of doing that is because of the various size widths of heam joints that will be placed in between these brackets. There's quite a few different sizes on the market. Say for an example, you got a 1/2 inch heam joint. So I would just make up the difference of your 1/8 inch bracket per side with your 1/2 inch heam joint bushing in between all your brackets where you would bolt to. And if you look close at this bracket, you can see these 3 holes and these 8 holes at the bottom. These are your actual 4-link mounts. This top hole is for the shock mount, which this is horizontally, so the shock would actually be coming off this direction. The 3 holes directly below that are for the adjustable wheelie bar mounts for your bottom of your wheelie bar. The top will mount to the top of the differential on the rear end. This hole here is a brace that will run from one side to the other side directly below the rear end. Possibility I might even countersink a couple holes in that and bolt it to the rear end as well as both sides of the 4-link brackets. That should keep it nice and sturdy. Should be plenty strong anyways, but just added precaution. appearance looks, I guess. Will make it look a little bit beefier. These 5 holes, or 8 holes rather, around here is the actual bolt pattern. This will be bolted to the rear end housing. 2, 5, 6 holes, pretty beefy. The hole in the center here is obviously the axle path. The axle will pass through this hole here. It is, right offhand, I don't remember the size. It is a little bigger than 1/2 inch, so I can have room for seal, to put a seal in there to prevent any fluid coming out from the differential. Should that pose to be a problem in the future, I can open up this hole, change that bolt pattern, change the dimensions if necessary. And probably what I'll do, this is on 8 inches by a 6-inch piece of material, 1/8 inch aluminum, T6 6061 aluminum, flat sheet, whatnot, what have you. Probably what I'll do is I'll run with 3M 467. It's double-faced tape, adhesive tape. I forgot the name. There's quite a few places you can get it from, though, but I've got quite a bit of it. Use it quite a bit. It will hold that stuff there, and it's not going to move around, because a lot of times it's only like 2 mils thick. It's a paper thin, pretty much. A lot of times when you're milling through your part like this, you figure you got your clamps there, here, and here. So when you get starting to mill around and you get close to your very last cut, if you're not holding that part down in the middle somehow, once it gets close to that last cut, it will vibrate free and hit that end mill and most likely bind up, and that part would go flying. Don't want that. A lot of times what you could do is you could just pause your operation. Say your last cut is from here over to here. You could pause your operation over here, take one of your clamps off of here, adjust it, bring it up, put it in the center, clamp it down there, and then continue your operation. That will stop that part from moving. I don't want to do that. I would rather just go with the double-sided adhesive sheet. What I'll probably do is I'll get a piece of Mike 6, because it's true, it's 100% flat, and I'll use it just for operations like this. I'll probably get a piece of Mike 6. Say my table is 10 inches by 18, so I'll get a piece of Mike 6. It's probably 8 inches. Excuse me, 9 inches by 17. That'll give me an inch leeway all the way around it, and I'll clamp that to the table. I'll actually just probably screw it to the table so it'll be a permanent fixture. And put the tape on that part, on the Mike 6. Place the part on the table wherever it's required to be at. Clamp the part down really good to it, so I know it's pretty flat on all 4 corners. Then I could remove my clamps and it shouldn't move around. Once the part is cut out, you could run a screwdriver under it and pull it up. It comes off fairly easy. Far as temperature wise, it withstands 300 degrees Fahrenheit. It's chemical acid resistant, so the coolant won't pose to be no problem there either. So all in all, I think I'll be fine going that route. I'll cross that bridge when I get to it, but we're going to go ahead and run this cam simulation so you could see how this operation is done. As I mentioned, this only takes 3 minutes 21 seconds. And here we go. It will take a second to start here. first operation is the 4-link mounts. And it is setting a peck rate. I'll go over that in a later video. Then your next operation obviously was the tool change there. Is the mount for the rear end where the 4-link bracket mounts to. Same size holes there for my other mounts. Obviously I changed tools there. Now we're doing the inside for the axle path to pass through. And change tools there. Open that up twice there to get a nice clean cut both directions. There'll be a total of 2 passes, removing 0.787 per pass. And this is real time. 3 minutes to do 1 bracket, that's not too bad. And it is done. 3 minutes, 21 seconds. I'll have to do this 4 times, obviously, to get 4 brackets. Not that big of a deal. If I did have a larger mill, I could easily put 4 of these in a roll horizontally, or nest them together and do all 4 of them at one time, but with limited y-axis at right around 4.5, 4 3/4. X-axis I have, I think, 9 inches, 10 inches. Nearly impossible without moving my table. I could do it and move my table backwards and forwards, but I don't want to mess with none of the geometry with the table. Once I get that all set out, I just don't want to mess with that, so don't need no brackets. It's not quite right. So that pretty much covers this video, and thanks for watching.